This presentation reviews the surprisingly limited conversational capabilities of Alexa and Siri. My name is Jeff Wilson, and I have worked on all areas of language technology for over 40 years. In case you are not aware of my personal history, I designed and built the world's first standalone connected speech recognizer, the Marconi SR128, and I have also worked on text-to-speech, speech coding, and language analysis. This slide provides some further background to the timeline. It shows Siri's debut in 2011, 13 years ago. Today my key interest is in intelligent, human-quality AI conversational assistants, and this presentation will focus on Amazon's Alexa and Apple's Siri ongoing inability to support such conversations. Simply put, they lack an essential mathematical component, as I will demonstrate. I uncovered this missing mathematics in 2016 when I discovered the fundamental theorem of cognition. My book, Precise AI, published in 2023, provides the background to my research. The text shown on this slide is taken from the book's back cover. The key insight comes from the geometry of language, just as geometry is now essential to modern biology. Alexa and Siri both demonstrate a lack of the essential mathematics that underpins the fundamental theorem of cognition. However, they also seemingly lack three other simpler but essential mathematical components. Firstly, the context equation, which reads, "A sentence when mediated by context resolves to meaning." Secondly, a verifiable mathematical theory for anaphor resolution. And thirdly, a standardized model for representing cognitive memory. My next step is to compare and contrast Alexa, Siri, and Hodgepodge data. Alexa was launched in 2014, and Siri was launched in 2011. Hodgepodge data is the Precise Intelligence research-focused AI assistant, which I will use as a reference. Coding started in 2016, and the first verification tests were run in 2020. ChatGPT is not included in this analysis for two reasons. Firstly, as a web scraper, it may have been trained on the test, and secondly, and more importantly, is the OpenAI advice. ChatGPT can make mistakes, check important data. Such advice precludes the use of ChatGPT for human-quality conversations, as it would require the memories created for each interaction, which provide the essential context, to be verified, so there could be no human-quality experience. So now let me start my tests on Hodgepodge data, Alexa, and Siri. I use short conversational tests, which I call smoking gun tests, to probe an AI system's capabilities. For this presentation, SG6026 has been selected. SG6026 is a very simple conversational test based on questions about the Olympics, and so it vastly simplifies the scope of the test by excluding unstructured statements, which Hodgepodge data can handle, but Alexa and Siri can't. SG6026 is just one of 100 distinct smoking gun tests that have been used to verify the new mathematics used in Hodgepodge data. A book, Precise AI Conversations, available from Precise Intelligence, contains 100 smoking gun tests, covering a wide range of language structures and concepts. The textual form of the SG6026 test on Hodgepodge data is shown here. Whereas the first question, who won the men's 100 metres in the 2012 Olympics, is clearly a standalone question, the meanings of all the other questions that follow depend on context. And what is context? It is the set of long-term unstructured memories. My own memories go back over 50 years, and clearly all such memories must also be discoverable. More background on this issue can be found in my book, Precise AI, where I describe the Antigone event. That insight should help you understand the importance of cognitive memories for AI and intelligence. You should note that in its responses, Hodgepodge data handles context effortlessly and also resolves anaphoric references correctly. Now let me play the short audio version of this test on hodgepodge data.
Who won the men's 100 meters in the 2012 Olympics?
Usain Bolt.
What was his time?
9.63 seconds.
Who came second?
Joanne Blake.
Who won the women's event?
Shelley-Ann Fraser-Pryce.
What was her time?
10.75 seconds.
Who came second?
Carmelita Jeter.
Who won the men's 200 meters?
Usain Bolt.
What was the time?
19.32 seconds.
Who came second?
Joanne Blake.
What was his time?
19.44 seconds.
This test on hodgepodge data demonstrates the appropriate use of the essential mathematical components for context, anaphors, memory and cognition in order to achieve a human quality conversation. Now let me attempt this test on Alexa. Alexa, who won the men's 100 metres in the 2012 Olympics?
Here's something I found on the web. According to Bartleby.com, in the 2012 Olympics, Usain Bolt of Jamaica won the gold medal in the 100-meter race with a time of 9.69 seconds.
Alexa, what was his time?
The time is 1:21 p.m.
Alexa, who came second?
According to an Alexa Answers contributor, Valtteri Bottas won the 2019 Australian Grand Prix. Did that answer your question?
No.
Thanks for your feedback.
Alexa, who won the women's event?
Here's something I found on the web. According to wikipedia.org, Camille LeBlanc-Bazinet won the women's event as the only competitor who went through the pull-up sequences unbroken.
Okay, so there doesn't seem much point in going on and asking the next question as to what was her time, because clearly we're well off any cohesive track of conversation. So let me just try a couple more selections from the test and see how we go. Alexa, who won the men's 100 metres in the 2012 Olympics?
Here's something I found on the web. According to Bartleby.com, in the 2012 Olympics, Usain Bolt of Jamaica won the gold medal in the 100-meter race with a time of 9.69 seconds.
Alexa, who won the women's event?
Here's something I found on the web. According to wikipedia.org, Camille LeBlanc-Bazinet won the women's event as the only competitor who went through the pull-up sequences unbroken.
Okay, I'll stop now. Of course, the person who won the women's event was Shelley-Ann Fraser-Pryce. But I think that's a clear enough demonstration that there is no concept of cohesion in the interface. Now let me try some questions on Siri. Who won the men's 100 metres in the 2012 Olympics?
I found this on the web.
What was his time?
I didn't catch that. Could you try again?
This was somewhat irritating as the speech recognition part of Siri understood perfectly. So it was Siri itself that couldn't answer the question, again because of a lack of cohesion. So let's have one more go. Who won the men's 100 metres in the 2012 Olympics?
Here's what I found.
Who won the women's event?
Here's what I found.
Now again, this is slightly more than irritating, as it gives 3 hits on the screen, and the first is about the Oxford and Cambridge boat race. So we have somehow switched from athletics to rowing without any reason to do so. Neither Alexa nor Siri seem to be able to engage in even the simplest multi-turn cohesive conversation. Almost the very simplest sports conversation with just 2 questions and using only pre-stored knowledge is: who won the men's 100 metres in the 2012 Olympics? Followed by, who won the women's event? This is a simple, cohesive human quality conversation, and one of the simplest examples for which cognitive memory is not merely desirable, but is essential for cohesive conversations. However, I believe the only way you can really experience the gap between the performance of current commercial AI assistants and cohesive human quality conversations is by trying such simple tests for yourself. The critical mathematical insight that has enabled hodgepodge data at a development cost of under $1 million to create well-structured cognitive memories and thereby effortlessly handle issues of context is the fundamental theorem of cognition. Let me list 3 important implications of this theorem. It is essential for cohesive conversations, hence clearly currently unknown to both Amazon and Apple. It is essential for standards-based document comprehension, which is not possible with generative AI. It supports low-power, quick-build solutions. This theorem also provides support for unstructured statements, not just commands and questions. Yet support for only commands and questions has cost Amazon and Apple over $10 billion each. So the essentiality of mathematics to support both context and statements should be clear. My understanding is that Amazon would like to monetize Alexa, which will most surely require context, and I suspect that Amazon would also benefit from a human-quality sports information service. With regard to Siri, a remark in 2019 by a Siri developer would seem to imply that Apple has no interest in the mathematics of context, which must surely be a bizarre viewpoint. Also, neither Alexa nor Siri seem to have any interest in precise mathematics for anaphor resolution. Although it is difficult to exactly estimate the impact of the fundamental theorem of cognition on development costs and timescales, it would seem reasonable to believe that this mathematics, with the added benefit of standardized representations, would reduce development costs by at least 20% and further enhance system capabilities. With regard to the future, the key mathematics developed by my company, Precise Intelligence, can be licensed for under $5 million. This is less than 1/2000th part of Amazon's and Apple's expenditure to date. Precise mathematics is the essential component for intelligent, human-quality AI conversations. The new mathematics makes it very simple to build systems that support cohesive conversations. So simple, in fact, that it is surprising that in Siri's 13-year history, Apple never discovered this new mathematics. Mathematics that enables human-quality conversations at significantly lower cost, faster timescales, and with more capabilities. All the evidence suggests that Precise Intelligence is the only company to have made the key mathematical breakthrough that enables intelligent, human-quality AI conversations.